A huge thanks to the Minister for all of his support. Hello everyone and welcome to Innovfest Unbound 2019. My name is Naomi and I will be your MC for the next couple of days. To stay up to date with all announcements, any happenings all around the festival, there's so much going on, please make sure you download the app, search for SNI Week in the App Store, and you'll find out what's happening at the other stages where some of you might find a seat. Please put your hands together now for our partner, SGInnovate's Steve Leonard and Grazia from Airbus as they discuss shaping the future of flight. Thank you very much.
Okay. I know we have some movement as different ministers and delegates go and find other things to be looking at, so we're going to jump straight in. I have the pleasure of having Grazia Vittadini here with us, and so I'm going to ask Grazia to start, first of all, by just introducing yourself, the Chief Technology Officer of Airbus, but how would you like us to think of you and what you do and your background, and then we'll get started.
Thanks, Steve. Yes. So, Grazia Vittadini, Chief Technology of Airbus, global leader in aerospace. We've been pioneering innovation for the last 50 years. We just had our birthday last month. With a very, very broad portfolio of products and services, so airplanes, helicopters, satellites, drones, unmanned air systems, connectivity solutions, urban air mobility, you name it. So what's my role in this? I identify, develop, mature, accelerate all those technologies which will be implemented in the products and services of the future for us to maintain our competitive advantage. So that's a quite awesome job, and I even get paid for it. Can you figure?
Okay. Well, what I'd like to do is I'm going to jump straight into a topic. I know you and I touched on it briefly when we saw each other earlier this morning. There's an increase in air travel as humanity grows, air travel grows, but there's always a concern about carbon, fuel, climate change. I know an area that you work on personally and that you're also thinking about for Airbus is electrification. So can you help us understand a little bit about how you're looking at the technology, how you see the role of hybrid propulsion from what it is today and what it might become, and some of the engineering challenges that go into trying to make batteries light enough to be meaningful contributors. So please.
Yes, sure. Very, very, very rightly articulated. So electrification is definitely one of the main ingredients which will enable us one day to achieve the ultimate goal of zero-emission aviation. So demand for air travel doubles every 15 to 20 years. Great business case, right? But we are persuaded that we need to cope with this success in a sustainable manner. Okay? So we're developing a set of technologies. It's not, you can't boil it down to one technology. It's a set of converging ideas which need to be developed coherently, concurrently, and electrification is definitely one of the main enablers. And with this respect, we're exploring several avenues, always with the idea of demonstrating in flight whatever we intend on implementing as a serial solution into our products. Our journey in electrification started already back in 2010 with the Cree, the first fully electrical trainer for engine trainer. Then we had the IFAN, the first fully electrical aircraft to cross the channel. And now, a couple of years ago, we launched IFAN-X, so RJ100 platform, where for the first time ever, we're going to be taking to the air a 2-megawatt electrical power unit. So just to give you an idea as a reference, an A320 has an engine of 20 megawatts. Okay, so it's a first trial of a very high power class, operated with a 3,000-volt circuit, which poses incredible integration challenges. Just think of short circuit protection, arcing problems at altitude, transient phases of such an electrical circuit. So we are testing it on ground in our facilities in Germany, and we'll be flying with the IFAN-X in 2021. It's a partnership with Rolls-Royce. And it's going to be really a demonstrator for us to learn how to integrate the electrical component into hybrid, serial hybrid configurations. Why is hybrid so important? Because as charming as electrical flight can be, it is realistically achievable on short term on flying vehicles of a limited capacity, okay? So for the urban air mobility case, absolutely, this is a viable solution. With the due developments, we think we could realistically envisage a regional type of 100 pax platform, let's say around 2030. This could be something feasible. But indeed, the limiting factor today are the batteries. Okay, so we've done the maths, and today the currently certified standard of lithium-ion batteries has an energy density of 100 watt-hour per kilograms. Now we are experimenting a new type of technology application, which allows us to go up to 350. And it's a solution which enabled the Zephyr, the high-altitude pseudo-satellite, to beat the world record in endurance just some months ago. So let's imagine to have something which is 10 times more performant than that, okay? So not yet certified. If you would apply that solution to a typical A320 aircraft, you would be able to fly only with half of the payload for 1/5 of the range. So the math, the physics, just do not enable to consider today a fully electrical solution on that kind of aircraft, where hybrid becomes a very interesting concept, something we are testing also on smaller scale aircraft. The EcoPulse has been recently launched, a project together with Daher and with Safran, where we are taking a turboprop, basically, and really installing electrically driven propellers to study the application of electrical flight only in certain phases of flight. For instance, takeoff and landing, which are the phases more delicate in terms of noise emissions. And we took some very, very ambitious commitments in terms of wanting to reduce our NOx emission by 90% until 2050, 75% reduction CO2, and 65% noise emission.
So one of the things that you just mentioned, you talked about physics. Let me come on to one of the topics that I know we both are excited about and think about in terms of future, quantum technologies. So this idea of what the constraint may or may not be. So as you run simulations, classical computing architecture may have a challenge in terms of the volume of simulation when you think about route optimization and weather patterns and so on. What role does quantum technology play in the future development for Airbus?
So, well, first of all, a disclaimer. I will not be scientifically accurate for the sake of making clear what type of potential we see, Airbus sees in quantum technologies. So, indeed, modern computers are reaching the limit of what they can do in terms of management of data, okay? So there's a limit to how infinitely you can shrink a transistor to make it fit onto a chip. Basically, that's what drives performance, okay? In the 60s, we had 2 transistors per chip. Now we're talking about billion of transistors. So there's a physical limit to how far you can go in that process. So we need a paradigm change. We need a quantum leap. That's where quantum computing comes into the picture. Where at Airbus, we're not quantum scientists. We have a very successful partnership with a startup in the United States, QCware, who is experienced in using quantum simulators, D-Wave typical machines. And thanks to this partnership, we really started studying the practical application of quantum computing to typical cases we meet when developing an aircraft. Typically, there's a lot of optimization you need to do, a lot of iterative calculations to converge to a solution. And with this in mind, we have launched at the beginning of the year a quantum innovation challenge, open challenge, where we posted on our site 5 typical problems which we are faced with. So flight physics and design type of challenges, optimizing the loading of an aircraft, optimizing the climb route, optimizing the design of a wing box, which is a very complicated part, having to fulfill many tasks, having to be light, having to have a certain design. So we posted these typical problem statements and invited the quantum community to translate these into quantum language for us to feed a D-Wave machine. And we were really thinking we'd have a handful of enthusiasts responding to that. You know, Richard Feynman, Nobel Prize for quantum mechanics 50 years ago or so, was saying nobody really understands quantum. So we were thinking it would just be a couple of geeks, but we're having hundreds of researchers, PhDs, scientists, really having a go at this. And we've already had also applications of the potential of quantum computing. You mentioned route optimization. So whenever you plan a route, you can choose to optimize in terms of time you spend in the air or optimizing fuel consumption. There's different parameters you can choose to optimize with. And just imagine you have to cross the Atlantic and you can map each single point of your route, taking into account also the incumbent meteorological conditions, winds, pressure, temperature, et cetera, et cetera. So that's something of a complexity which would take weeks for standard computers to process, and that's where the potential of quantum simulators.
So please make sure in the middle of everything else that you're doing, you also keep an eye on what the Center for Quantum Technologies here in Singapore, as part of NUS, is working on. Some exciting things. As a person who flies a lot myself, and as you do, as a tech optimist, I tend to be excited about more systems being able to further improve safety and reliability and efficiency. But I know there's this intersection of automation and autonomous, or autonomy. So more automation assisting versus autonomous, in which, in theory, there isn't somebody. Can you talk to us a little bit about how you see automation in aviation and where you think it may go? Is there a future in which a fully autonomous environment is there, or do we always want somebody in the front seat just in case?
Yes. So, well, first of all, our products are already largely automated. Think of a satellite, of an unmanned air system by definition, and also our aircraft. An A350, an A380, weather permitting, have an auto-land function, okay, which practically allows the smooth landing.
Yes.
The pilot just operates the flaps and the undercarriage. So automation is already embedded in all what we do. Now, if we project, again, the aviation industry 20 years in front of us, we see that trend I mentioned before, demand for air travel increasing. The projections indicate that we could be needing 600,000 pilots in 20 years' time, whereas today, we are at around 200,000. So we will be facing shortage of pilots. There's also, of course, an economy factor to that for the airlines. So there is, let's say, there's different factors which concurrently, including the fact that automation and safety go hand in hand, and the statistics are clear about it. So if you see the level of automation in aviation and the accident rate, so 2017 was the first year, for instance, where there were no fatalities in commercial aviation. So the trend is absolutely positive. And safety comes first at Airbus and then in the industry as a whole. That's something you never compromise on. So all these trends converge, and on our autonomy roadmap, indeed, automation transitions into autonomy with the ultimate ambition of having fully autonomous aircraft.
Yeah.
Now, that will not happen anytime soon. It took us 60 years to go from 4 to 3 to 2
in the cockpit.
in the cockpit, right? So it will take some time.
Yeah.
But on the way to that ultimate ambition, there's a lot you can do and a lot you can demonstrate on step-by-step basis. And that's where we're looking at, for instance, understanding what would it mean to have one single pilot in the cockpit instead of two. So that implies a transition from automated to autonomous systems, where what's the difference? Basically, the routine of automated systems and automation being able to deal also with the surprise, with the out of ordinary type of events, right? With a certain mimicking of the human component, which could be potentially taken over by artificial intelligence.
I wish we had time to talk about things like artificial general intelligence and the idea of can a system become aware and think in a way that a human, but we're not able to do that. Just to summarize briefly, because we're out of time, unfortunately, Airbus, under your leadership in the CTO office, is thinking about electrification, is thinking about quantum technology, is thinking about the journey from automation to autonomy, and I know additive manufacturing and so on are also part of your roadmap. Part of the goal for Unbound and Innovfest is for entrepreneurs and scientists and people that are working on cool things to see and be a part of new journeys. So it's a great pleasure for us to have Grazia here to share her vision on some of the exciting challenges in aviation and some of the opportunities in aviation. So if you're thinking about some of these issues, please know that Airbus cares about and is thinking about these issues too. Thank you very much, Grazia.
Thank you, Steve. Thank you.
Thank you very much, Steve, and thank you, Grazia.